Hello everyone, and welcome to the CSE116 Task 1 Game Features 1 Overview. That's right, this is the overview video for Task 1 Game Features 1 at CSE116. In this video, we're going to be getting right into some of the key features of Task 1 Game Features 1. What might be confusing? How might I solve these problems? We're going to get deep into this, we're going to talk about it. How can we approach these problems? We're going to do it all, alright? We might see a snake later, like, what? Snakes? We're going to have to find out. And then we'll have a game like this. Doesn't this look fun? Wrong. This is not fun. This is the incomplete version of part 1 of Task 1 Game Features 1. Let me show you how it's going to look when it's done. Oh my god, this is so cool. This is awesome. As you can see, I'm not colliding into the walls. I could move. I could walk around the level, I could get hit by the enemies, importantly, and I can make it to the next level. Whoa, do you want to see the end? Well, you gotta make this yourself. Isn't this awesome though? This is a real game. You guys are gonna make this. And, hey, that's not all. I knew you guys, all of you wanted more, so let me show you some more. What else is in this awesome game features portion of Game Features 1 Task 1? Ugh, what is this? Is this the unfinished version of Snake of Game Features 1 Task 1 of CSE116? See what I did there? Oh, this is horrible. Man, sorry guys, let me fix this really quick. Whoa, hey, who did that? Oh my gosh, this is Snake. Oh man, it's a little loud, but wow, this is Snake. This is the complete version of Snake. This is awesome. So guys, as you can see, I'm having like an insane amount of fun right now, and you all are going to be able to make this. This is Snake, you know, the Snake that you all know and love. So I mean, like, wow, this is great. You guys are going to make this, and there's so much fun to be had here. You're going to learn so much through this Task 1 of Game Features 1 Task 1. So let's get right into the document and explore. Hey Josh, this isn't the document. Hey, I know, but what this is something to show you guys that, hey, if you hover over this video and move your cursor along the bottom, there are chapters for different segments of this document that we're going to go through. So if there's a certain part that you're confused on, you don't want to watch the rest, that's fine. Just skip right there and learn what you need to learn. So with that being said, oh, wait, actually we have a few more housekeeping things to be aware of. So first of all, guys, listen, hey, I respect it. Some of you went and watched last semester's Game Features 0, Task 0 video, whatever, right? Which is fine, you probably learned a lot from that. However, there was something last semester that was applicable that is no longer applicable this semester. And that one thing is that a lot of you have been marking the source folder as sources root. Now, what does that mean if you don't know? Well, see this blue Java folder right here in your project? This is the sources root of this project, right? So it should be this Java folder. This blue folder should be Java, okay? You should not be right-clicking on source, finding mark directory as, and then go to sources root. You should not be doing that. If this Java folder is not blue, then make sure you right-click it, hover over mark directory as, and click mark as sources root. I already have it marked, so it currently says unmark as sources root. But keep that in mind, all right? Do not change this Java folder from being sources root if it already is, okay? All right, and one more thing I want to talk about here really quick. If you don't know where I am in the configuration file of this project. And if at any point, by the way, I'll probably bring this up a few times here and there, but if at any point you cannot find a file in this project, because, you know, let's admit there's a lot of files in here, a handy dandy trick is pressing your shift key twice, which, you know, is only applicable if you're in IntelliJ, which you should be. So hit shift, and now you could type the name of any file. So I'm going to type configuration, and I'm already in there, but I'll hit enter, and it would bring me right here. So if I was in settings, shift, type configuration, enter, boom, now I'm in configuration. Okay. Now that we're here, you know, you guys did Game Feature 0 and all that stuff. But just to reiterate, this public static final string game, this is going to be very handy when we're testing our games. We get to switch this to whatever different game that we're going to be testing. So for the first part of this task, I would definitely say we should switch this to sample game, right? Because if we switch it to sample game and then hit play, well, we get that because my version doesn't have parse level implemented yet, but from game feature 0. However, you guys will probably see something different, something similar to what I showed at the start of the video. So yeah, I would definitely change this to sample game for your testing. And yeah, so let's get into the document. All right, no more funny business. Let's get into it. So, all right, everyone. By the way, before this video actually begins, just want to clarify that you guys should have already read the document, and if you're confused about stuff, then this is a good video for you. But it's good to read it first. You want to have your first glance at everything. So yeah, there's some important stuff at the start. There's only a few things you're gonna modify in this task. You have the coordinate system, which to some of you, to most of you probably, it was to me, is kind of weird, right? Because the coordinates go increasing down towards the bottom right, right? You can see that from this chart here. The document does a good job explaining that, so I'm not going to go too deep into it. But yeah, we're working with coordinates that go further down the bottom right. So that's something definitely you want to keep in mind when we're doing our math and stuff. So we read all that and we scroll down to the specification section, and we see that we have to modify some methods in the physics engine class. So if we remember, so I'm there already, but let's say I wasn't in physics engine, I was somewhere in configuration. I want to find physics engine, like I said earlier, shift, type physics engine, enter, boom, I'm there. And then I can scroll through all these methods here, and this is the first one we got to make, update object, right? So we go back to the doc. So update object, huh? Sound familiar? It should, classes and objects. So this object is not, it is an object, but it's a dynamic game object, right? Which is something specific to our game engine. Okay. So update object, as this says here, should update the location of the dynamic game object, which is a class, based on the velocity and amount of elapsed time. Okay. So what does this mean? All right, and then it goes into some more specifics of how we could actually do this. So first of all, let's take a look at this method, right? We are given two parameters here. A double dt, which means delta time, which is the time elapsed since the last update, okay, in seconds. And then a class dynamic game object, which is given to us as an object, okay? The ones that you guys have learned, classes and objects. This is an object, an instance of the dynamic game object class, but it so happens that we're calling it object as well, because in our game engine, this is a dynamic game object, right? And if we were curious of hey, what is going on inside of dynamic game object, we could hold down control and click on dynamic game object, and we could read all about it, right? We get to see everything here. And what is it doing? Oh, well, dynamic game object extends game object. Okay, we go into game object. It, does all this stuff. It implements two interfaces. Great. You might not care about that stuff. That's fine. You don't have to care about it. All you have to do is kind of understand that dynamic game object is a class, and we're given an instance of that class, an object, which we could now modify, access its getters and setters, all that. So, but we want to talk about the actual specifications. I'm going to close this tab of this. Actually, no, I'm not. Of this method. So, what does update object actually do? Well, let's take a look at it. Oh, wow, this diagram looks great. Oh, yeah, I know. So, all right, we got a position and we have a velocity. All right. Now, it's understandable if you don't know too much about velocity. This is kind of physics stuff. That's fine. All right. It's not too complicated what we have to do here. So, we have two vectors. What is a vector, you might ask even? Well, if you don't know, a vector is basically, at least in terms of how we're going to use them, at the most bare minimum level, they are objects that have two values, an x and a y, that are doubles, okay? So here this is x. Oh, let me label this as x, and this is y. So the position of our player is a vector 2D, that is a x and a y. So 0, 0. So position, this is our position at 0, 0. Great. Now we don't only have to store just positions as vector 2Ds. We could hold other data as vectors as well. So velocity is a vector 2D. That is 1, 0. X is 1, y is 0. Now what's different here is we choose to interpret this vector 2D differently for our purposes of the game. So when we have a vector 2D, which is we're calling velocity, that is 1, 0, that means that we want our current velocity to be going 1 in the x and 0 in the y. Now, that's better described here with my visual of this arrow, okay? So these black dots here represent position, and this blue arrow represents the velocity, okay? So velocity is 1, 0, so we move 1 unit to the right. Okay, that's what we want to do. At the time the updateObject is called, right, we get the position of the player, and we want to update it based on the velocity of the player, okay? But that's not all. We also have to scale the velocity by delta time, change in time. Now, some of you might wonder, like, why are we doing this? Well, if we didn't do this, remember, games run on a very high frame rate per second, let's say 60 frames per second, right? So this updateObject method is going to be called every frame. Does it sound right that if our velocity is 1, we want to be moving 60 units a second? No, right? If our velocity is 1, we want to be moving 1 unit a second, right? So we have to multiply by the change in time. And whatever the change in time from the last frame is what we need to scale our velocity by to get this movement in a second, right? This is much more normal, and it scales things correctly, right? So this is the most basic example I could give of this, right? Now we could look at another one where this is basically the same exact thing, except our delta time is 0.5, right? So if it took half a second between the last frame and this frame, which is, we don't really care about that. It's given to us in updateObject, right? dt. Then we scale our velocity by delta time, which is 0.5. So it would be delta time times our x and times our y to create this 0.5, 0, because 0 times 0.5 is 0, right? So we only move in the x. Now, I get that, this, you might be understanding how this math works, but how do we actually change this value in our object, in our dynamic object? Because we see that we have a delta time dt, but where is this position? Where is this velocity? Remember, if we look inside the dynamic game object class and we scroll down, well, first of all, we could already see that there is a velocity here, right? And very nicely, there is a getter for the velocity, right? Vector2D get velocity, it returns the velocity. Awesome. Now you might be saying oh, what about location? I don't see a get location. That's the beauty of this thing called inheritance, which we're going to learn all about. But because dynamic game object extends game object and we go into game object, we're just waving our hands at this right now, but we're going to go deeper into it later in the semester. But the game object class has a instance variable location and a respective getter for that. So because all of that stuff is there, if you care about it, cool. You don't have to care about it. All it means is we could do object.getLocation. All right. And so remember, okay, getLocation returns to us a vector2D. Okay. So boom, right there. Vector2D location is object.getLocation. Now remember, okay, a vector2D, we could go inside the vector2D class too, right? Objects are passed by reference, okay? This means that when we call object.getLocation and we store it inside this location variable, this is pointing to the same place in memory as this object's location variable here, right? So they're pointing to the same object in memory. So there is one vector2D floating somewhere on the heap in memory, okay, which we've been learning about, and we access that object in the heap with this getter, okay? Because the vector2d is a class, and an instance of that class is being stored inside this dynamic game object, and we're just getting that reference, okay? So if we were to do location.setX to some number, then we are actually changing the location of this object. We're not like, this is not a copy of the vector on somewhere else on the heap. We would actually be changing the location of this object, okay? That's something to keep in mind. But what we could also do is vector2d velocity, and that's just, as we'd expect, object.getVelocity. So now we have location and velocity just like we do in this image here, and we could probably start to think about how we want to do some of this stuff. Now, something that to keep in mind, right? So some of you might think like that we maybe will want to make a new vector 2D for like this new scaled velocity. You know, you guys could totally do that, but just try to keep in mind that these references here of these vector 2Ds are references to the actual vector 2D of the data inside the dynamic game object. So we do not want to be like changing this velocity here, because this will change the actual dynamic game object's velocity when we might want to like make a copy of it and, you know, scale it by the delta time. So, all right, there's that. And here's just one more quick example here, a little more complex of this is supposed to say velocity, and this is 1, 2. So, and remember, 2 is not up in this project, it's down. That's positive direction, so like we got 0, 1, 2, 1, whatever, that's actually 4. All right, yeah, you get what I'm trying to say though. 1, 2, 3, 4. Because delta time is 2, so we scale our vector by delta time of velocity, and we go from 0 to here, okay? Now remember, position doesn't have to be 0. It could be something else. So, which means that like we have to actually get the position of the game object. But this is updateObject, okay? So shouldn't be too hard, but the hardest part about this is being comfortable, you know, with objects in Java and, you know, some basic math and being able to move around things. But once this is all done, you will be able to move inside the game engine. So currently you're stuck, but you'll be able to move, and similarly to how I showed you at the start of the video, you'll be able to move. Okay, so cool. Let's move on to the next part of this task. All right, so next is getOverlap, but sorry, I just remembered that last semester I actually explained this amazingly, right? Just phenomenally. So I'm going to play a clip of me explaining everything about getOverlap from last semester. However, just keep in mind, if you notice some changes in the wording of the document when I'm going through it, don't worry about it. It's the same concepts, okay? So, you know, focus on the wording in this document because it's better. It's just meant to be better clarifications and stuff. But the concepts are the exact same, so don't like freak out if you notice that. But all right, good luck with him. I'm sorry. Okay, so we have to complete the given getOverlap method. Now, as we can see with this picture here, we want to return a double, so I'm reading right from the doc here, representing the minimum overlapping distance of the two objects. So, of the two hitbox objects. So, a lot of you guys are probably familiar if you've played games, you know what hitboxes are, like even like competitive games are like, oh, come on, I should have hit him, when the hitbox is like actually a little smaller than the model, or whatever. So you might have heard of hitboxes. It's basically just this, it's a box around the actual sprite or model of the object that will deal with the collision logic. And engines and games do this because it simplifies things. Like, as you can see, this rock shape is like pretty like dynamic, and it's a lot easier if we just calculate the collisions with the box. So we do it like that. Now, the getOverlap method, what it's really saying is it's trying to get the it's trying to get the distance, the smallest distance it needs to leave the overlap. Okay, think about that for a second. So as this sentence here says, we would return 0.25 if the x overlap is 0.25 and the y is 0.5, we would want to return 0.25 because it's smaller in the x and we'd want to get out the smallest way possible. Okay? Now, the reason why I'm trying to word it so explicitly like that is because of an edge case that I found that we should look at really quick. Here is a special case where we have a hitbox in the middle that is completely engulfed by the second hitbox. Now, in this scenario, if you were just thinking like that we're returning the overlap area, some of you might think that we want to return 0.5 because that's the smallest overlap distance between these two hitboxes, right? So of course, like, you guys might have not had time to just read all of these points here, but the width of this is 0.5. So it goes on 2 on the x, and then 2.5 on its second x point. So the width is 0.5. And the height is also 0.5. So that's the smallest overlap between these two hitboxes. But that's not actually what we want to return. We want to return the smallest distance to get this hitbox out of here. So that's going to actually be, if each of these units is 0.25, it would actually be 1.5 because we'd want this hitbox to move to this point right here. That's the smallest distance that it can move to get out of this bigger hitbox. Now, a lot of you guys are probably like, whoa, how am I supposed to calculate this? It's a pretty like daunting thing. And I'll be honest, it's not trivial. We have to look at this problem and boil it down into smaller problems so that we could solve it. And this is a good exercise. Just, this is math right now, basically, but translating it into programming, like, this is a skill that you guys are going to use all throughout CS. So let's take a look at this. I drew up some examples here so that we could look at this a little better. Now, first thing that I'll say is that this method becomes insanely easier if we consider the x and the y dimensions separate. And the handout does say that you should do that. I believe somewhere right around here it says, somewhere it says that you should test the x and y's separately and then return the smaller of the two. Okay, that's very true. We should totally do x and y separately, because if we try to do this as one just big picture, like both at the same time, it's going to get really messy. So let's consider these separately. So I drew out two sets of images here, one for the x and one for the y's. So for now, let's just look at the x's, okay? And in fact, let's just look at this guy right here, okay? So if these two hitboxes, okay, we have a black and a gray hitbox here, and their points are labeled according to their color. So if these two hitboxes are overlapping in just the x dimension, we are only considering the x dimension here, then the distance that they're overlapping is d right here, which is, and I'll draw it out, d, which is equal to x2 minus x1. Okay? So think about that for a second. That's the distance that if these two hitboxes are overlapping in the x, it is distance d. Now, some of you might be thinking, like, what if it's not d? Like, what if this hitbox is actually on the left and this one's on the right? Well, we have another example for that, which is this down here. So this one is a little different because now d here is equal to x2 minus x1. Now, note that these two distances are different. Like, they are different because we start with this x2 here and then this x2 here. So these two are different, but they're two real possibilities that can happen if these two hitboxes are overlapping in the x. So what we need to do is we need to consider both of these cases. I'll name this one D1 and then this one D2. Distance 1 and distance 2. And we need to consider this distance and this distance and see which one is the smaller of the two. Okay, because now I'm drawing these hitboxes like this, but like I get that like some of you might be thinking like these, like they might not be looking like this. And I would agree, 99% of the time they're not going to look exactly like this. But first of all, remember, I'm completely getting rid of the y dimension here because we're going to do that separately. You know, that's over here. We're going to talk about that in a minute. But we're only talking about x's, so that they have to be squished to this one y here because we're not even considering y's. And on top of that, we're saying that if they are overlapping, this is how we'd calculate it. Okay, this is how we'd find that overlap. And we have to consider it two different ways. If one hitbox is on the left, and if the other hitbox is on the left. So we have to consider those two different ways, which leads to two different formulas here. You know, this distance and this distance. And then we have to compare them and see which one's smaller of the two. So whichever one is smaller, we take that distance and we'll label that as the x distance. Okay, the x overlap. Okay, so let's just leave that at there for a second, okay? And let's say that that's going to be our x overlap. Now let's take a look at the y's, okay? Now, if we look at these images here, we might realize that, wait a second. This is the exact same image as this, literally just flipped on its side. Like, it's the exact same thing. But we have to consider it just slightly differently because, like, it's the y's, but it's the same exact logic here. Nothing really changes. So when we have our distance d, and we'll say this is d1 as well, this distance is going to be equal to y2 minus y1. Okay? And similarly here, this distance, or sorry, d2, is going to be equal to y2 minus y1. And it's the same thing where we want to compare these distances. So we would see which one is smaller, and we would get the y distance, or I guess, yeah, y distance. Okay, so we would compute these two values for both x and y, and find the smaller distance for each of them. Okay, so now we have the value of the x overlap and the y overlap, and we know for a fact that it's the correct value because we have the minimum overlap. Like we took the minimum here of both the x and the y's. Okay, and now we have one last step here, and it's actually not too hard. All that's left is now to compare our x and the y's. Oh boy, this is going to be big. Now we just have to compare the x and the y's and see which one is smaller for those two. And then at the end of the day, when all that's said and done, we just get our distance, aka, we'll do aka overlap. So, and this is our value. This is the method. It's a lot simpler when we break it down to x and y's separately, and then we compute the overlap. Like we're basically like boiling it down to the smallest pieces, and then taking something out of those two small pieces, taking something out of these two small pieces, comparing those together, and getting one final overlap or distance. And if they weren't overlapping at all, then the value here is going to be either 0 or some value less than 0, which that's fine. We just got to return that as well. If we look at the method specification on the actual doc here, if they're not overlapping at all, we should return 0 or a number less than 0, which that will naturally happen with our math logic here. So if you don't fully understand this picture, I would take a second and try to like really think about it. Maybe go through some test cases and follow through this logic of this picture, or draw your own pictures and see if you could start to understand the examples here. Now, in this class, not many, like, we're not going to make so many methods that are like very math based, but this one's pretty important because especially in game engines, collisions are a big deal, and we got to make sure we're calculating this stuff correctly. So that's how we do this, okay? I can't walk into too much specifics of how exactly to write this in code, but if you look at all of the variables we're using here, like we're using like all of my labels here, like you could translate these directly into code pretty much. If you know, obviously you can't have two variables named x1 and x1 here, but if you think about it, you know, it's technically like this is a black x1, this is a gray x1, so like take that as you will, however you want to, you know, label these things, but this is pretty much how it's going to work in code. So, and whenever I'm drawing these little arcs here, that means like take the minimum. So keep this in mind, you know, look at this for a bit, try to figure out if it makes sense to you. But the good news is once you complete that, the rest is pretty easy, or at least easier than that. So detect collision, this is extremely trivial after you completed getOverlap. All you need to do is, as it says here, you take your getOverlap and basically just return if they're colliding. So I'm not going to give this one away too much because it's very simple. Just read it. You will be able to do this in not too long. Okay, trust me. But collideWithDynamicObject. Now this one's interesting because it sounds like just as hard as getOverlap, but the good news is if you follow the same approach that we described for getOverlap, you could almost pretty much copy and paste a lot of the same exact code for collide. Because collide, we're still looking for the smallest distance, okay? But here's the thing. We want, once we get our smallest distance, so it's literally going to be almost this exact same thing. But once we have our x and our y's, excuse me, we still want to find out which one is smaller, right? So whichever one is smaller, we want to, okay, so let's say the y overlap is smaller. So, okay, we take this y, and then we want to move the dynamic object away from the wall, because that's what we're doing in this method. We're writing collide in the wall class, okay? Collide with dynamic object in the wall class. And here, I'll just show you guys what it looks like, just so we're fully clear here. So we're in the wall class, and we're given a dynamic game object, right? But it's very similar because if we looked at the physics engine, the getOverlap method, we're given two hitboxes, right? And we're going to return the overlap when it's all said and done. Now, in the wall class, we still have those two hitboxes. It's simply hitbox 1, or sorry, hitbox, we could even name it the same thing. Hitbox 1 is just equal to the wall's hitbox, okay? And it's very similar for hitbox 2. It's just the dynamic game object's hitbox. It's a very similar thing. We are still trying to get those distances, right? But whichever one is smaller, the x or y's, we want to move the dynamic game object that distance away from the wall. So that means that we have to just think about for a second, like, okay, am I going to move up? Like, if we're considering the y's, all that's left is like, okay, we have the y distance. Should I move the dynamic game object up the y distance or down the y distance? And I'll let you guys think about that a little bit. It's actually not too hard to solve this problem here, because we just got to see like where that dynamic game object is in relation to the wall. Like, let's say our wall is here at this location, because remember, locations are marked in the top left of the object. And let's say our dynamic game object, which I'm marking like this blue, is like right here in relation to the wall. So we already made it to this stage. Like, we already know we want to move the y distance, which we could also see from this visual. That's the smallest way to move out of here. And we just have to decide at this point, should we move up or down? Now, if you guys could probably tell me the answer just by looking at it. It's like, well, we should move down. This distance is like, it's way easier to move down. So think about why you're saying move down here, okay? It's going to be useful if you compare their locations to figure this one out. So think about that. I won't say the exact answer for this one because you could use pretty much the exact same logic from the getOverlap up until this point, where then you have to decide. And again, if you have to consider those cases the same for the x's in this method. But overall, you have to do a lot less work if you did your getOverlap correctly. So yeah, once you figure out, okay, I want to move down, then you just want to update the location of the dynamic game object to move down that distance. And then you want to turn off, basically, the velocity in the y for the dynamic game object, which, remember, we could modify those values directly. So if we said, like, okay, I want to move this dynamic game object, or I want to, let me find the exact wording from the doc here. Yeah, we want to set the velocity of the dynamic game object to 0. So, let me find this for a second. Where is that? Yeah, so right here. Its velocity in the x direction would be set to 0. If we moved it in the x, we just have to set the velocity in the x direction to 0. So remember, since we're dealing with objects, okay, which means like other object has a velocity directly. So .getVelocity, then we have the option to either set x or set y, okay? And that will actually change the velocity of the dynamic game object. So keep those in mind, okay? That's the bulk. Like this, that is the coding part of, all the logical methods inside of the LO for this task. I get if you're overwhelmed, but it really will help you if you start drawing some pictures and taking time to think about this, because it is a tough task, and it will only get easier if you practice and fail and accept the failure. And also, it'll be easier if you write your tests. Whoa, hey, Josh, I'm gonna have to stop you right there. You did great, buddy. However, we gotta talk about testing a little differently this time. So this is one of the changes made from last semester, right? You guys are given all of these tests for getOverlap, collideWithDynamicObject. You should run and debug using these tests as you implement these methods to guide you. Which this is like amazing. You guys should like be doing this like all the time. You should be going to test task 1 and like right clicking it, run test task 1, and watching things happen and watching everything fail until it passes, right? Once you write the stuff right, these will pass. Okay, so definitely be doing that. This will make your life a lot easier. But snake, right? We all love a good snake, right? So, first things first, it tells you to change the game to snake. We know that, right? We did that earlier. But so now we're doing some snaky stuff in this portion of the task, which pretty much everything you guys do, literally everything you guys do, is going to be in the snake level class, all right? So there's 1, 2, 3, 4, 5 methods to write. So let's take a look at them each and just see what's up and go into the snake level, which, by the way, you could do shift snake level, bam. They're all right here, empty for us to implement. Perfect. All right. So let's talk about wallOffBoundary. So as you can see here, this is a level.
It's a crafting table.
You might think it's not, but trust me, it is. This is the level of which our snake will be playing in. Okay. So this level, you can see it's a square. It's got a width and a height. Interesting. Very interesting. We want to wall off the boundary. So if we take a look here, right? We actually have an example. A 2x2 levels top wall will span from -1, -1 to 2, -1. So let's remember here, right? First of all, we have to know that this stuff is, like, just conceptually, we have to know that when it says 2, -1, this is the top part, right? The lower the y's go, the higher we are. I know it's weird. Let's just not think about that right now, okay? We have bigger things to worry about. We can talk about it after we get all the points. So we go in here, right? And we have an example, right? This level could be, who knows how wide this is, right? It's some width, width, all right, and it's some height. And what we want to do is place walls around the boundary, as it says. So just to make sure we understand everything here, I'm going to label these walls in blue. We want these walls essentially to go around the whole level like this, okay? We want the boundary of the level. So, if this point right here, this right here is 0, 0, this point right here would be -1, -1, as the document says, -1, -1, to 2, -1. But, clearly this isn't 2 in my example. I know, I'm sorry, I drew a snake and all these other things. But this is some other number that's y, it's some x, and its y is -1, because, it's still at this level. But it's some x, But, what is the x? Well, this is the width of the level, right? So, with that, we could maybe think about what the width is, okay? And we have a similar thing with the height. It's just the same thing, but the other way around. So, what we want to do, right, if we look at the document here, we want to be adding static objects around this perimeter, okay? And we do that with the add static object method. So, if we just type add static object, we see which method we have here, and we want to be creating snake walls, specifically snake walls, okay? So, just an example of that, snake wall equals new snake wall. How we make an object. We should start to be getting used to this by now. And then we give it some x and y, So if we were like hard coding this, which we're not going to do, of course, we would, we could, from our example, just say that it's at -1, -1. Cool. Now we have a snake wall, and we could add it to our static objects, okay? Cool. This is going to be wrong and everything like that, but that is how we would do it. So here's some other things that will probably be useful to you when implementing this method. If we scroll up, we don't see that we have a width and height in this class. However, since snake level extends level and we go into level, we have a width and height. What that means is that in this method here, wallOffBoundary, we are able to access this dot width, or we could do get width. Either way, you'll get a width. You're able to access this, so we could even make a new answer like width equal this dot width, or you could just directly use this dot width. That word's getting hard to say. And same thing for height, this dot height. Okay, cool. So we're able to access these values, and we want to surround this width and height with snake walls. Okay, what's the difference between a snake wall and a normal wall? Read the code. All right, I don't know. You can look at it yourself. It seems pretty simple actually. So that's that. That's wallOffBoundary. Okay. This, for almost all of these things, like it's almost always helpful to draw pictures. They're just helpful. So that's wallOffBoundary. All right, let's move on to spawnFood. All right, so this method, spawnFood, is a great example of, hey, let's just try some things out. Let's get our hands dirty a little bit. Okay, so spawnFood is, this big requirement, one snake food should be added to the level upon spawnFood being called. Okay, so far so good. And you also need to add it to the array list food. All right, so we have to do two things. We know for a fact we have two things to do by the end of this method: add to food and add snake food to the level, which we could do with the add static object. Okay, so far so good. Now, if we could read the rest of this. There's snake food needs to be random, and it can't be in these 4 different locations, right? It cannot be violated by any of these points. Okay. Now, if we were to keep reading, we would notice that any random number generation must use the randomizer class. Okay. Now, let me tell you guys, let's take a close look at this randomizer class, specifically the random int vector 2D method, okay? So, if we call randomizer, this is a static method here, so, all a static method means, by the way, if you don't know, is that to use this method, we don't need an instance of the class or an object, okay? So we don't need to do like randomizer name equals new randomizer. We don't need to do that because random int vector 2D is a static method, okay? Which just means that we could call it right from the class, okay? So let's take a look at random int vector 2D by holding control and clicking on it, okay? And so we see that this is an overloaded method, right? Which means that this is a method with the same name and return value, but there's two different definitions of it with different parameters, okay? Now, the neat thing here is we notice that one of them just takes a vector 2D upper bounds. The other one takes a vector 2D upper bounds and an array list of vector 2D's exceptions, okay? So, no matter how complex you thought this method was going to be to write, it just got a lot easier. Because now we realize that, oh, this handy util that we have here will give us a position that excludes a bunch of positions, right? So, if we go back to the document, we see that all of these positions in these points should be excluded, okay? So the direction of our problem starts to become a little clearer, okay? We know for a fact that the method that we were supposed to use takes an array list of vector 2Ds that we don't want to be in our position, right? So our problem turns into, how do we get this array list of exceptions to pass into this method, okay? So this is basically the bulk of this method here. How do we get that array list? How can we populate that with everything that we don't want in the snake food to be, okay? Also, don't neglect these edge cases down here that say, some edge cases that you do need to make sure that you take care of. These are like, edge cases. We got to make sure that we implement them, but the bulk of the, difficulty is not here. These are like, some if conditions that we're going to have to write here or there. But this is like the bulk part of it, okay? How do we get that exceptions array list? And, how can we use it? So, this is just a lesson in like, all right, when we have utilities for us to use, make sure we're reading them fully, right? So random vector, int vector 2D, let's like make sure, like read this documentation, right? Just understand what it's doing and try to use this method. And this basically like, I'm going to totally say it, but it kind of writes itself once you have that array list of exceptions. So, think about that. And let's move on to lengthenSnake. lengthenSnake. Quite a fun method, guys. All right, so this one here, okay, we have to add a certain amount of snake body objects to our tail array list, which is in our snake level class, okay? So we have tail here, this is what we want to add to. Now here's the thing, right? There's some different conditions on how we should position the snake body object, and also like we have to do it a certain amount of times, potentially more than once, right? So we have to add a length increase amount of snake bodies, okay? And what I mean by that, this is an instance variable in our snake level class, right? Length increase. So this is some value that, could very well and most likely will be more than one. So this is like probably the thing that complicates this method the most, or so you might think, okay? So lengthenSnake, right? how this problem is gets very hard if you try to think of this in terms of adding multiple snake bodies at once, okay? But I'm here to say, nay, we shall not do it that way. I'm here to suggest a simpler way to approach this problem, okay? Let's think of this one at a time. How do we add one snake body object, okay? So, this document, like this description of the method explains it honestly, as if we only have to add one, other than this little mention right here. Like it says, for each new snake body object, okay, one snake body object, the location will be decided as follows. And it's dependent on if the tail array list is empty. So, we're looking at like an if-else here. So this problem becomes very easy if we just think about it as adding one snake body, okay? Because the conditions of adding a snake body, right? After we add a snake body, no matter what, we know that the tail isn't going to be empty after that. So we could honestly do like, write some piece of code that we could use multiple times. Think about, how we could do that, right? Multiple times that does the same exact thing for length increase times, okay? So think about that. It's the way we position it, it's pretty simple besides the first condition. Whereas if the tail array list is empty, it has to be directly behind the head of the snake, which the head of the snake is returned by this .getPlayer. So let me just show you this. And the head is actually a player, like you play as the head of the snake, and that is in terms of the lore and all that. So I won't get into the lore. It's like 10 pages long. So right now we'll just focus on the game. So player, okay, equals this .getPlayer. You're like, how is this magic happening? This is insane. Guys, come on. Remember, level has a method. getPlayer. We could even find it here. getPlayer of app.gameEngine.level. It's right here. Cool. That's what we're using, okay? Our snake level extends level. So we're able to use this fun stuff. Where's snake level? Okay. So, player. This .getPlayer. This is our head of the snake. So, if we want to be like lore accurate and everything, we should call it head. Okay? So, one nice handy dandy thing about our player here is that our player has an orientation. Head.getOrientation gives us, and this is a vector 2D. Remember earlier how I was like, guys, we could use vector 2Ds in so many different ways to interpret so much different data. Well, orientation is another way that we could interpret this data. So orientation, oh no, vector 2D, blah, 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 and import that. Okay. Oh, by the way, if you're wondering, it did kind of just tell me how to do it. If you're wondering how I did that, import static method, that's definitely not what I want to do. What I wanted to do is import this vector 2D. Oh, here we go. Vector 2D. So when I see this here, I could either press enter. That wasn't enter, that was a backslash. Enter, and then it will import it automatically at the top, somewhere vector 2D. Or alt enter will do that. That's what I did earlier. Anyways, I'm getting too much in the weeds of that. Orientation equals head.getOrientation. Okay, so we're organizing our variables here. Guys, I'm not just doing this for show. When I write my code myself, I write very explicit names. We get all our variables in one place. It's how you can write nice, clean code. So we have the orientation of the player now, and now we could decide, given, I'm writing that there just to show you guys, how we could get the orientation. But remember, like, we only want to do that if our first condition of our if statement was met, okay? So, fair warning there, but, that's what I'm saying. And, some very useful fact here is that the orientation vector will always be one of these four. So just keep that in mind. And also be aware that the vector 2D method has a dot equals, but yeah, okay, you can use dot equals. So, you could compare two vectors, or you could compare their components directly. Orientation.getX, is how you get the x of a vector. So yeah, just laying it all out there. But, you know, other than that, it's important to, you know, see this little tidbit at the end here that whenever you add to the tail array list, you want to add to the start. Otherwise, you want to prepend, not append, okay? So this, don't overcomplicate this part. Doing that is as simple as adding one more parameter to the add method, as this literally like basically tells you. So keep that in mind, okay? Let's talk about spawning the snake, okay? Lore accurate, of course. And everyone, all right, it's important. Let's not overcomplicate spawnSnake here, all right? No one should be pulling their hair out over spawnSnake. If you don't have hair, well, you wouldn't be pulling it out anyways, okay? So spawnSnake, it works almost the same way as lengthenSnake, but it's based on the starting length variable instead, okay? And, you know, it reminds you, you should, you know, add the new snake body objects to the level with add static object and the tail array list, you know, yada yada. So just don't overcomplicate this one, all right? You know, just think about what we said already about certain things. You know, it should do stuff in the same manner, but it's just the different variable really that you're changing. Instead of length increase, you know, starting length. Don't overcomplicate spawnSnake, all right? Spawning the snake, don't rip your hair out over that, all right? We got Snake to play. And remember, once this is all done, we will be able to play Snake for hours on end. So, the last method, moveSnake. Now, you know, this is one of those methods, you know, where I'm going to say again, don't overcomplicate it. But, you know, there's some, you know, niche little things in here and there that might trip you up. So, to better prepare you all, I wrote a little song. Here goes nothing. All right, just kidding. I didn't write a song, but I did draw this little diagram. Hopefully this helps you guys understand more. So, all right, this blue little square here, right? This is our snake's head, all right? To, you know, wait, sorry, let me give it a lore accurate face really quick. All right, and that should be good. All right, so I just drew this little sketch real quick. This is our head. All right, so if we look at the document here, right, which, you know, I'm not looking at it, but I remember it. So this snake, so there's the whole thing about moving the body parts and whatever. All right, you know, we could talk about that in a second. But where I want to start is moving the head of the snake, okay? So moving the head, remember how earlier we got the orientation of the player, which was the head of the snake, you know? So when we want to move the head of the snake, we want to move it by the head's orientation, okay? So let's select an orientation here. These right here, these are our orientations. So, you know, I'll label that really quick. Do that. Orientation. All right. That says orientation. Okay. So let's pick an orientation here. I'm going to pick this one. All right. So 0, 1. All right. So if our player was facing 0, 1, that's our player's orientation, the head's orientation, right? It should move exactly 1 unit down 1. Okay? You know, this is, you know, it makes sense when we draw it out, of course, you know, which is why we draw things out. So now we're going to choose this one right here, -1, 0. We're going left, so of course we're going to go left 1. And remember, orientation is always going to be one of these 4, so it's, you know, all we're doing is basically taking the location of our snake and adding the orientation to it whenever we want to move it, okay? So that makes sense. So, you know, I'm going to, you know, pretend this is, you know, the snake. You know, let me make it little. Yeah, okay. So, you know, we're moving 1. We're going to move again. Maybe this way this time. This way. You know, every time we're calling moveSnake, it's going to be like this. Of course, we're missing the whole tail thing, right? So, the thing about the handout, all right, I'll be frank, all right? There are 2 different ways, or maybe multiple different ways, you know, to do this problem, right? To move the snake's body the right way. So I'm going to draw out 2 of the ways of how we can move the snake's body. So first of all, we need to give this snake a body, right? So perfect. Okay, so now this snake has a body, right? Makes sense. So here are 2 ways to move it. Okay, now there's going to be some weird pixels all around, but let me just ignore it, okay? All right, so let's say our player's head is currently right here, okay? Which it will probably be something like this at the start of our method, okay? If this is where our player's head is, okay, there's two ways that we can move this snake. One way, the way that probably most of you would think about, right, is by moving this up one, okay, and then by moving this up one, and then this one up one, and then this one to the left one, okay? Boom, we moved our snake correctly. And we just keep doing that over and over, you know, until you know, we have moved every body part to the right place, okay? Now, it takes me a long time to drag these boxes, right? And every time I'm dragging this box, you know, like, we have to move every single body part like this, okay? So this is one way to do it, okay? Here's another way to do it, okay? So let's say we move the snake's head to one more position, right? Some of you might notice that in all of our previous examples, these three parts stayed in the same position. So we could utilize that property, right? And instead of moving every single one up by one, we could basically remove this guy from the end of the tail, bring it to the top, and set its location right there. Okay, so now, whenever we move the head, all we have is a very simple operation where we just, you know, we move this here, boom. That's going to mess things up. Let me just do that. Yeah, so just like that, right? So we could keep doing it like this, and now we have our snake moving happily along. So now I'm not necessarily recommending one way or the other. If the first way makes a lot more sense to you, you can see how immediately how you'd code that up. Go for it, do it. But I want to let you know the second option is there, and it could simplify things a bit, depending on, you know, pick whatever makes the most sense to you, okay? One thing, though, I do want to mention about this is some things that might be useful to you, may or may not, depending on what approach that you go with, but some array list methods that are neat, okay? So this dot tail is our array list of snake body, okay? So there's a few things here that are nice. First of all, there is two methods, get first and get last. Gives you either the first or last element of those array lists, right? Useful, okay? There is also remove first and remove last, okay? You know, maybe remove first more, but yeah, those exist as well. So just keep in mind that there's some very useful methods here. And also, now that I'm thinking about it, I do want to mention this part at the bottom. When you're updating like the location of the player and all that, the handout does mention that there's some nice, easy ways to do like the math, arithmetic with vector 2D objects, which are like vector 2D dot, and we could see a whole bunch of arithmetic that we could do. I don't know why this is red. There we go. Vector 2D dot, you know, there's multiplication, addition. We could add two vectors, division. But, you know, in this example, you'd probably want to add two vectors. So keep those things in mind, okay? And other than that, in this method, yeah, so at this point, like, this is like, if you think about it simply, you're not going to have to write a lot of code in this method, okay? Try not to overcomplicate it. Try some things out. See what happens in the game, right? Try to, you know, it's listed last here for a reason. Try to get some of these other things made. But then once you're here, you know, play the game. Try it out. See what works and mess around, right? But, you know, make sure you're reading all these bullet points very much in detail. And draw your own pictures, right? So this, you know, this shows one exact approach of how you could do it. It boils down the problem into like, how do I move this guy down here in the tails array and move it up here, right? It changes the problem a bit to a simpler problem. You know, when you're thinking of all this stuff at once, you know, I have to move the body parts and the head, like it gets complicated, right? All right, everyone. That is it for this task video. Hey, I know it was a long one, but, you know, we discussed some important stuff here. So, what I gotta say is good luck with this task. You know, make sure you're giving it an honest effort. Come to office hours if you need it. We're here to help. We'll talk about whatever you need to talk about, you know. But give this an honest try. You know, we provide you with a lot of given tests. Use those tests. And, well, that's all I got. So, I'll see you guys in the next video. Later.